So then let's look at some of the applications of nanotechnology in foods. So again, there's a whole series of different ways that you can employ nanotechnology to enhance the food supply. And I'll just give a few examples here. So one of the ways is to make sort of food ingredients invisible, which sounds a bit weird, but you can do. So for example, say you wanted to make a transparent beverage. So you want a clear beverage and you want to put an oil-soluble component in it. So normally when you want to put an oil-soluble component in it, it wouldn't mix with the water and you would just get a layer of oil on the top. Or if you use conventional homogenization technology, you would make something that's a few hundred nanometers and it would scatter light very strongly and it would look something like milk. So it would look very creamy. But if you use special fabrication methods, you can make a system which has got fat in it, but it looks transparent. And the way you do that is by making the particles very, very small, so much smaller than the wavelength of light. They scatter light very, very weakly, and therefore they look clear. When the particle size is about the same as the wavelength of light, they scatter light very, very strongly, and the sample looks turbid or cloudy. So this is one application which the beverage industry is already using to put oil-soluble flavors and colors and vitamins into sort of beverage kind of products. And this is just some of the work we did in our lab where we were trying to make different kinds of delivery systems for nutraceuticals, so in this case curcumin, and we've made like phospholipid nanoparticles or protein nanoparticles made out of zine or lipid nanoparticles made out of corn oil. And in some cases we can make transparent systems that we can incorporate into sort of clear beverages. In other cases, we need to get the particle size smaller. And then we've also looked at the bioavailability of the nutraceuticals in these different systems and the chemical stability of them in these different systems. And they're all slightly different from each other. So you have to choose the right kind of food-grade nanoparticle for the particular application you're working on. Another thing you can do is to use nanotechnology to increase the shelf life of foods. So I live in New England, and in New England, we have like a big microbrewery craze. So everybody's trying to make the new kinds of beers using all sorts of weird and interesting ingredients. But you often see like you get these precipitates in or sediments in beer, and you get them in other kinds of food products like dressings or plant-based milks and things like that. So using nanotechnology, you can try and improve the shelf life of these products and improve the stability of the products by making the particles very small. And there's two ways you can do that. One is it helps prevent particle aggregation, and the second way is it helps stop creaming and sedimentation. So we look at creaming and sedimentation first. So if you have a particle in some kind of food product, you typically want it to stay stable so the product looks homogeneous. But any particle, there's two different forces that are acting on it. One of them is gravity, and that will tend to make the particles move upwards. And then the other one is Brownian motion. So this is like the random collisions by the molecules in the solvent around it. And this wants to randomize the system. So this wants to make it homogeneous. Brownian motion wants to make it homogeneous, and gravity wants all the particles to go to the top of the product or to the bottom, depending on the density difference. So what you find is that gravity increases as the particle size increases. So things will tend to separate more quickly as the particles get bigger, whereas Brownian motion tends to increase as the particles get smaller. So when the particles are small enough, the gravity forces are very weak, the Brownian motion is very strong, and you can prevent creaming or sedimentation from occurring. You can also change the stability of particles to aggregation. So when particles aggregate, they often cream or sediment faster. So this was an experiment we did a few years ago where we made protein-stabilized emulsion droplets, and we made them either large or small, and we calculated the colloidal interactions between them. And what you find is if you have very small particles, the colloidal interactions, so the attractive forces between the particles, are very, very small. So these are so small, these attractive forces, that the emulsion stays stable and the product can have a very long shelf life. If the particles are bigger, the attractive forces are much stronger, and then you tend to get aggregation and creaming of the droplets. So again, this is an example where making the particles very, very small, you can improve the shelf life of a product. So that was looking at the physical stability of foods. So the other thing you can do is improve the chemical stability of food ingredients. So this is an example where we have a nutraceutical called curcumin, which comes from turmeric, which is supposed to have lots of health benefits. And we dispersed it in water, or we dispersed it in a nanoemulsion. So if you put it in water at around neutral pH, it will tend to chemically degrade very quickly. If you put it inside a nanoemulsion, it's much more stable. And the reason for that is because the chemical reactions occur in the water phase. So when this is surrounded by water, it undergoes certain types of chemical reactions which causes it to degrade. If it's in the oil phase, it's not in contact with the water molecules anymore, and it's much more stable. Okay, so the last area I'll talk about is things like using nanotechnology to increase the bioavailability of bioactive compounds in foods. So these are things like vitamins or minerals or nutraceuticals. So nutraceuticals are these natural molecules that are found in foods that have almost act like pharmaceuticals. So they have some health benefits if you eat them at a sufficiently high level for a sufficiently long time. At least it's claimed that they've got some health benefits. So things like resveratrol in grapes or wine, or curcumin in turmeric, or capsaicin in red pepper, or the carotenoids like lycopene in tomatoes. So what we're interested in is, can we incorporate these bioactive components into foods to make foods into functional foods for improved health? So what we do normally is we take these nutraceuticals, we encapsulate them in these nanoparticles, and then we incorporate these nanoparticles into functional foods. And what we're interested in is trying to understand what happens to these nanoparticles inside the gastrointestinal tract. So really there's different levels of nanotechnology you can use here. So first of all, you need nanotechnology to make your functional food. So you have to develop some like lipid nanoparticles to put in your bioactive agent. And then when you eat them and they go through your gastrointestinal tract, the food gets digested by enzymes and acids and mechanical forces. And you get a new set of nanoparticles formed inside your gastrointestinal fluids. So you get things like micelles, which are about 5 nanometers big, and you get things like liposomes, which are a few hundred nanometers big. So we've got these new kinds of natural nanoparticles formed in your gut. And then these get transported through the mucus layer, they get into your epithelial cells, and then they get into the sort of cellular apparatus, like the endoplasmic reticulum, where the fatty acids and monoglycerides are reassembled into triglycerides. And then these triglycerides are packaged into a new form of nanoparticle that your body makes. So in this case, it's lipoproteins. So they've got fats and bioactive agents in the core, and then they've got phospholipids and proteins on the surface of them. So, and then these will travel through your lymphatic system, get into your bloodstream, and then carry these bioactive molecules around your body. So what you're trying to do is use nanotechnology to control the food, the digestion, and the formation and size and characteristics of these lipoproteins to try and make foods healthier. Okay, so far I've been talking about using delivery systems to encapsulate nutraceuticals that are isolated from nature and then to incorporate them into functional foods. So some people would prefer to leave the bioactive components in the natural food product. So for example, you might want to eat a carrot because carrots have got carotenoids in. So, but what you find there, if you just eat a carrot on its own and you measure the amount of carotenoids that get into your blood, it's very, very low. So most of the carotenoids just go through your body. So what we came up with is this idea called excipient foods. And what we wanted to do is use nanotechnology to create a new generation of foods that if you ate these foods with fresh fruits and vegetables, that you could actually boost the amount of these healthy compounds that got into your bloodstream. So what we envisaged is that these foods could be something like a nano-enabled cooking sauce, or nano-enabled cream that you put onto your fruits and vegetables, or nano-enabled salad dressing. So our idea is that if you take these together, you're going to boost the bioavailability of the nutrients in the foods. So again, just like we can with other kinds of nanoparticles, we can create these excipient foods and we can play with the composition and structure of the food. So we can change the fat content, we can change the composition of the fat phase, we can change the type of emulsifier that coats the fat droplets, we can change the particle size, or we can add additional ingredients, so things like chelating agents, antioxidants, efflux inhibitors and things like that to these foods to try and improve the bioavailability. So I've been through quite a lot of material, but that's only the tip of the iceberg of how nanotechnology is being used. And I think there's lots of really, really interesting applications still waiting to be developed, and lots of other ones that people are working on. So things like trying to make nano-enabled sensors, which can give you information about the freshness of fruits or vegetables, so that we can reduce food waste by eating foods when they're high quality and only throwing them out when we know that they've gone off or have been contaminated with organisms. Or we can make sort of active or smart packaging. So we can use nanotechnology to put antimicrobial nanoparticles in packaging that slowly leaks out over time so that it preserves the food for longer. Or we can use nanofibers, so things like nanocellulose or nanochitin, to strengthen packaging materials. So we can make biodegradable packaging materials to replace plastic and all the problems you have with conventional plastic. So the challenge is to make these economically viable, and also to make them robust enough to actually use in real food applications. But I think there's been a lot of progress made in this area. And the last thing I want to mention is sort of food nanotoxicology. So we've done a little bit of work in this area. And there's especially in Europe, there's been a lot of concern that when you make particles very small, they behave very differently inside your body. So if they behave differently, they might behave in ways that we don't expect. So they could have potentially some toxic effects. I think this is, I have a joint position with Harvard University, and I work with Philip Democrito there, who did some really great work on toxicology on nanoparticles. And a lot of the work he's done has shown that there doesn't seem to be a big concern with most of the nanoparticles that he looks at. I think the ones that can be problematic tend to be inorganic nanoparticles. So things like titanium dioxide, which has been banned in France, but other kinds of inorganic nanoparticles that can't get broken down in your gastrointestinal tract and get absorbed by your body. If you have things like lipids and protein and polysaccharides, they will tend to get broken down in a normal way in your gastrointestinal tract. Although there can be some potential problems with that as well. So we always have to take that into account when we're developing these new food products. So just to conclude, there's a whole series of different organic and inorganic nanoparticles we can use in foods. They can be natural or processed. They have a wide variety of different applications in the food and agriculture industry. One of the areas that we've found is very useful for nanotechnology is to encapsulate bioactive components, stabilize them in foods, and then increase their bioavailability after they've been ingested. But in the future, I think we still need to do work to make sure that any of these nanotechnologies are safe for use, and look at their potential toxicity, because we're feeding millions and millions of people and we don't want to have any adverse effects.